Hi guys, this is Arvind here from MindMajix, and today I welcome you all to this amazing session on Kubernetes interview questions. So if you're looking for a job as a DevOps professional, Kubernetes plays a very important role. It's a very important tool as far as DevOps lifecycle is concerned. So in a typical DevOps interview, you can expect questions from Kubernetes. And also nowadays, there are various roles related to Kubernetes, such as, there's a role called Kubernetes application developer. There's also a role called Kubernetes admin. So in this kind of interviews, you can expect questions on Kubernetes. So it is very important to know the basics. So in this session, we will try to cover maximum questions related to Kubernetes so that once you clear all these questions, you are most likely to clear the interview. So before moving ahead, I want you guys to subscribe to MindMajix YouTube channel and also hit the bell icon so that you never miss an update from us. So without any further delay, let's get started. So the first question here is, what is Kubernetes? So Kubernetes is an open source container orchestration system for deploying, scaling, and managing the automated application. It offers an excellent community and works with all cloud providers. Hence, it is multi-container management solution. So this was a quick definition of Kubernetes. So the next question you might expect is, what is a container? So containers are a technology for collecting the compiled code for an application when it is required at runtime. Each container allows you to run repeatable standard dependencies and the same behavior whenever the container runs. It divides the application from the underlying host infrastructure to make the deployment much easier in cloud or the OS platform. So the next question here is, what are the advantages of Kubernetes? So if you talk about the advantages, so Kubernetes is open source and free. It is highly scalable and runs in any OS. It provides more power than Docker Swarm. It provides scheduler, auto scaling, rolling upgrades, and health checks. It has a flat network space and customized functionalities. It is easy to make effective CI/CD pipelines using Kubernetes, and it can hugely improve the productivity of the application. So these were some of the advantages of Kubernetes. So after this, the next question that you might expect is, what are the disadvantages of Kubernetes? So if you talk about the disadvantages, so the installation process and configuration is a bit difficult. It is not easy to manage the services of Kubernetes, and it takes up a lot of time to run and compile. After this, it is more expensive than the other alternatives, and it can be an overkill for simple applications. So these were some of the disadvantages of the Kubernetes. So the next question here is, what is the Kubernetes architecture? So the Kubernetes architecture provides a flexible coupled mechanism for the service. It consists of one master node and multiple containers. The master node is responsible for managing the clusters, API, and scheduling the pods. Each node runs on the container runtime such as Docker, RKT, along with the node that communicates with the master. So this was a brief overview about the Kubernetes architecture. So if you explain this thing, you can expect much more questions related to Kubernetes architecture. The next question here is, what are the main components of Kubernetes architecture? So the two main components of the Kubernetes architecture are the master node and the worker node. So each node contains the individual components separately. So let's just move on and discuss the next question. Define the Kube API server. So the Kube API server is the front end of the master node that exposes all the components in the API server. So it provides the communication between the Kubernetes nodes and the master components. So again, this question was related to the architecture part of Kubernetes. So the next question here is, what are the nodes that run inside the Kubernetes? A node is a worker machine or a VM depending upon the cluster. So each node contains services to run the pods, and the pods are managed by the master components. So the next question here is, what are the services that a node gives and its responsibilities? So the services that are included in a node are container runtime, Kubelet, and kube proxy. So the container runtime is responsible to start and manage the containers. The kubelet is responsible for running the state of each node and receives commands from the master to work on it. And it is also responsible for the metric collection of pods. The kube proxy is a component that manages the subnets and the services that are available for all of the other components. So the next question here is, what is a master node in Kubernetes? So a master node is a node that controls and manages the set of worker nodes and resembles a cluster in Kubernetes. And the next question following the same line is, what are the main components of the master node? So the main components of the master node that help to manage the worker nodes are first, kube server. So kube server acts as a front end of the cluster and communicates with the cluster through the API server. Next, you have the kube controller. So kube controller is nothing but it implements governance across the cluster and runs the set of controllers for running the cluster. And the third component here is kube scheduler. So it schedules the activities of the nodes and holds the node resource to determine proper action for triggering the events. The next question here is what is a pod and what it does. So pod is a group of containers that are deployed together on the same host. It is the basic execution unit of Kubernetes application that can create or deploy Kubernetes unit of object models. So Kubernetes pods can be used in two ways. First, pods that can run in a single container, and then you have the pods that can run on multiple containers when it is required to work together. Moving on, the next question here is what are the different types of multiple container pods? So there are three types of multi-container pods. The first one is the sidecar. The sidecar pattern is a single node pattern made of two containers of the application. It contains the core logic of the application and it sends the logic files to the bucket. Next is adapter. It is used to standardize and normalize the output application or monitor data for aggregation. It performs restructuring, reformatting, and can write the correct formatted output for the application. And the third type is ambassador. It is a proxy pattern that allows connecting other containers with a port on the local host. So these were different types of multiple container pods. So the next question here is what is namespace in Kubernetes? So a namespace is used to work with multiple teams or projects. It is used to divide the cluster resources for multiple users. The next question here is mention different kinds of namespaces in Kubernetes. So there are three types of namespaces in Kubernetes. The first one is the default. The default namespace is used when the cluster comes out of the box with no other namespaces. Next you have is kube system. So this namespace is for objects created by Kubernetes. And the third one is the kube public. This namespace is created automatically and it is visible and readable publicly throughout the whole cluster. The public aspect of this namespace is only convenient and reserved for the cluster usage. So moving on, the next question here is how are Kubernetes and Docker related to each other? So Docker provides the lifecycle management of a container and the Docker image builds the runtime of a container. The container runs on multiple hosts through a link and orchestrated using Kubernetes. So Docker builds these containers and helps to communicate with multiple hosts using Kubernetes. So this is how Kubernetes is related to Docker. So the next question is mention the differences between Kubernetes and Docker. So now we will be comparing Kubernetes and Docker based upon a few parameters. So the first point of comparison here is the installation and cluster configuration. So as far as Kubernetes is concerned, the installation process is very complicated, but once it is done, the cluster is robust. Now, if you talk about the Docker, so Docker installation process is very simple, but it does not have a robust cluster. The next point of comparison here is the auto scaling. So Kubernetes can do auto scaling, whereas if you talk about Docker, it cannot do auto scaling. The next point of comparison is the data volumes. So Kubernetes can store data only with other containers on the same pod. Whereas if you talk about Docker, so it can store data on any other containers. The next point of comparison here is logging and monitoring. So Kubernetes has an inbuilt tool for logging and monitoring. Whereas on the other hand, Docker uses a third-party tool, which is called ELA stack for logging and monitoring purposes. So these were some of the differences that you must mention when you encounter this question, the difference between Kubernetes and Docker. So let's just move on to the next question. The next question here is, why do we need container orchestration in Kubernetes? So container orchestration is used to communicate with several microservices that are placed inside a single container of an application to perform various tasks. So there are various uses of container orchestration, such as it controls and automates various tasks, such as deployment, scaling, and so on. It reduces the complexity of running time, and using container orchestration, scaling becomes terribly easy. Next, it is used to deploy and manage complex containerized applications. And finally, it reduces manual setting up of services. So these were some of the reasons that we need container orchestration in Kubernetes. Moving on to the next question. What are the different tools of container orchestration? So there are many container orchestration tools that provide a framework for managing microservices and containers at scale. Kubernetes is one of them. And apart from Kubernetes, you also have Docker Swarm. And there is one more tool called Mesos from Apache Foundation. So these were some of the tools for container orchestration. The next question here is, what are the major operations of Kubelet as a node service component in Kubernetes? The major operations that are performed by Kubelet are: first, it is a node that communicates with the master components to work on all the parts of the Kubernetes cluster. Next, it merges the available CPU memory and disk of a node into a large Kubernetes cluster. Next, it provides access to the controller to check and report the status of the cluster. And finally, it is responsible for the collection of metric pods. The next question here is, mention the list of objects of Kubernetes. So the objects that are used to define the workloads in Kubernetes are: first, pods, then you have replication sets and controllers. Next, you have deployments, and then distinctive identities. After that, we have stateful sets and daemon sets. And finally, we also have jobs and cron jobs. So these are some of the objects of Kubernetes. The next question is, what is the difference between a pod and a container? So pods are the collection of containers used as the unit of replication in Kubernetes, whereas containers are the set of codes to compile in a pod of the application. So containers can communicate with the other containers in the same pod. So I hope this answer highlights the difference between a pod and the container. The next question is, explain stateful sets in Kubernetes. A stateful set is a workload API object used to manage the stateful application. It is used to manage deployments and scaling the sets of pods. The state information and other resilient data of stateful pods were stored and maintained in the disk storage that connects with the stateful set. So the next question here is, how to determine the status of deployment. So to determine the status of deployment, you can use the command such as kubectl space rollout space status. So if you run this command and you get the output, it means that the deployment has been successfully completed. The next question here is, explain replication controllers. So replication controllers act as supervisors for all long running pods. It ensures that the specified number of pods are running at the runtime, and it also ensures that a pod or a set of pods are homogeneous in nature. It maintains the desired number of pods in the cluster, and if at all there are extra pods, it will automatically terminate them. If replication controllers detect a failed pod, then the controller will automatically replace the failed pod. The next question here is, what are the features of Kubernetes? First, it provides an automated and advanced scheduler to launch the containers on the cluster. Next, replacing, rescheduling, and restarting the containers that are failed while compilation. Next, it supports rollouts and rollback for the desired state of the containerized application. And finally, it can scale up and scale down as per your requirements. So these were some of the features of Kubernetes. The next question here is, what is kubectl? So kubectl is the command line tool that is used to control the Kubernetes clusters. It provides the CLI or the command line interface to run the command against clusters to create and manage Kubernetes components. So the next question here is, what is the Google Container Engine? So the Google Container Engine is the open source management for the Docker containers and the clusters. So this Kubernetes based container engine supports only the clusters that run within the Google public cloud service. The next question is, mention the various container resource monitoring tools. There are various container monitoring tools such as Grafana, Heapster, cAdvisor, InfluxDB, and Prometheus. The next question following the previous question is, what is a Heapster? So Heapster is a performance monitoring and metric collection system. It provides cluster-wide data aggregation by running with a kubelet on each node. It allows for the collection of metrics, pods, workloads, containers, and other signals that are generated by the clusters. So the next question here is, explain daemon sets. So daemon set ensures that all the eligible nodes run a copy of the pod, and it runs only once in the host. It was created and scheduled by the daemon controller. It is a process that runs in the background and it does not produce any visible output. So the next question here is, what are the uses of daemon sets? So daemon sets are exceptionally well suited for long running services that includes first log collection, next node resource monitoring using frameworks such as Prometheus. Next, it is used for cluster storage, and it is also used for infrastructure related pods such as system operation. So it is common for one daemon set to deploy one daemon type across all the nodes. However, multiple daemon sets can also control one daemon type by using different labels. So Kubernetes labels specify deployment rules based on the characteristics of individual nodes. So the next question here is, explain replica set. So a replica set is used to maintain a stable set of replica pods. It is used to specify the available number of identical pods. It was also sometimes considered as a replacement for the replication controllers. The next question is, what is etcd in Kubernetes? etcd is the distributed key value store. It stores and replicates the configuring data of the Kubernetes cluster. The next question here is, explain Ingress controller. So an Ingress controller is a pod that acts as an inbound traffic handler. It is responsible for reading the Ingress resource information and processing the data accordingly. The next question is, what is the based selector that is used in the replication controller? So the replication controller uses the equity based selector that allows filtering by labels, keys, and values. It only looks for the pods which have the same values as that of the label. The next question is, explain the load balancer in Kubernetes. So the load balancer is a way of distributing the loads which is easy to implement at the dispatch level. Each load balancer sits between the client devices and the backend servers. It receives and distributes the incoming requests to all of these servers. And now, following the previous question, the next question is, explain the two different types of load balancers. So the two different load balancers are, one is an internal load balancer that balances the load and allocates the pods automatically with the required configuration. And the other one is the external load balancer that directs the traffic from external loads to the backend pods. The next question here is, what is a Minikube? So Minikube is a type of tool that helps to run the Kubernetes locally. It runs on a single node Kubernetes cluster inside a virtual machine. The next question here is, what are the uses of Google Kubernetes engine? So there are various uses of Google Kubernetes engine, such as it creates the Docker container cluster. Next, it resizes the application controllers, and it also creates the container pods, load balancers, services, replication controllers. Then it updates and upgrades the container cluster. And finally, it helps to debug the container cluster. So these were some of the uses of Google Kubernetes engine. The next question here is, explain Prometheus in Kubernetes. So Prometheus is an open source toolkit that is used for metric-based monitoring and alerting the application. It provides a data model and a query language, and it can provide details and actions of metrics. It supports the instrumental application of language for many other languages. The Prometheus operator provides easy monitoring for deployments and Kubernetes service besides Alert Manager and Grafana. The next question here is, what is the role of clusters in Kubernetes? So Kubernetes allows the required state management by cluster services of a specified configuration. So these cluster services run the configurations in the infrastructure. So there are few steps that are involved in this process. First, the deployment file contains all of the configuration that is fed into the cluster. Next, these deployments are fed into the API server. After that, the cluster services will schedule the pods in the environment. And fourth, it also ensures that the right number of pods were running. The next question here is, what is the cluster IP? The cluster IP is a default Kubernetes service that provides a link between the pods or map container port and the host port. It provides services within the cluster and gives access to the other applications which are inside the same cluster. The next question here is, what are the types of controller managers? So there are different types of controller managers that can run on the master node, such as endpoint controller, namespace controller, service account controller, replication controllers, node controllers, and token controllers. So with this, we have come to the end of this session on Kubernetes interview questions. We have tried to cover maximum questions here. So if at all you face such questions in the interview and if you answer them successfully, you are most likely to clear the interview related to Kubernetes. So if you have any queries related to this session, then you can write them in the comments box below, and we will try to resolve your queries as early as possible. So thank you so much for being with us.